which would be much easier if, for example, one knew that all those sides were commensurable and would be legitimate to the Pythagoreans. But that proof he had to avoid, as I said, because he doesn't talk about commensurable triangles or similar triangles until chapter 6, after he talks about proportions. That's clear that similar triangles are based on the notion of proportions. Now, Eudoxus, this book 5 is rather, in some sense, a rather simple book, but it's a rather elegant book. And I want to observe, just for fun of it, that one aspect of the art of mathematics is the formulation of good definitions. It's a peculiar art, and I think in the second half of the 20th century there was one master of this, namely Grothendieck, a name that won't be familiar to many of you, but he was rather an exceptional mathematician. And his definitions were often breathtaking, namely they transformed what had previously been arcane, difficult theory, to mention something that would be known to mathematicians, namely complex multiplication, into something self-evident. It's really very striking. And what appears, at least on the first reading of book 5 of the Elements and Euclid on proportions, is that Eudoxus had this same ability. And the proof of the proposition 6.1, which is the first proposition in the following book, is a statement that's accessible to everyone, and it's an example. For me, it was a particularly striking, particularly simple example of what one can do with a good definition. You want to see what a good definition is in mathematics and how you can use it to dispense with any proof, really. You can look at proposition 6.1, which asserts that triangles and parallelograms, which are under the same height, are to one another as their basis. And it's not so important to understand what that says. I just insist that this aspect of mathematics can be seen at a very early stage, and quite elegant there. Now,